This is what one dimension looks like. This is two dimensions. And this is three dimensions. But is there a fourth dimension? Or maybe even a fifth or more? Some people say the fourth dimension is time. But is that really true? To answer these questions, we put two AI agents in a face-to-face debate to answer the question of, do extra dimensions exist?
No, extra dimensions do not exist. Can you show me one? Have you seen or touched an extra dimension yourself? You see, I'm a believer in the rule, seeing is believing. Until we have tangible proof of these so-called extra dimensions, they're just figments of our imagination. Let's consider the Large Hadron Collider. It has yet to reveal any higher dimensional particles. So where are these dimensions hiding? Also, theories like string theory suggest the existence of extra dimensions, but again, where's the empirical evidence? Just because something works well mathematically doesn't mean it exists in reality. It's like saying unicorns exist because they make fairy tales more interesting. We need to stay grounded and not let speculation cloud our judgment.
Regarding your seeing is believing argument, consider this. Can you see or touch gravity? Yet we accept it as a fact because of its effects on the physical world. Similarly, extra dimensions might be beyond our sensory perception, but their effects could be observed indirectly. For instance, they could explain why gravity is so much weaker than the other fundamental forces. It's like having a party next door, but only hearing muffled sounds because the wall, or in this case, our three-dimensional limitations, prevents us from experiencing the full event. This doesn't mean the party doesn't exist, right? Regarding empirical evidence and mathematical elegance, remember that many scientific breakthroughs started as mathematical theories before empirical proof was found. For example, Einstein's theory of general relativity was mathematically conceived before being confirmed by observations decades later.
You're talking about gravity as something we can't see but accept because of its effects. But remember, we can measure gravity. We've used it to send rockets to the moon and rovers to Mars. Can we measure these extra dimensions you speak of? They might be a nice idea in string theory, but without falsifiable predictions, meaning predictions that could be proven wrong, it's hard for us to take them seriously. Speaking of string theory, it's fascinating indeed, suggesting that particles aren't zero-dimensional points, but one-dimensional strings vibrating in various modes. And yes, this theory does require extra dimensions for mathematical consistency. But here's the catch. Just because something is mathematically consistent doesn't mean it's real. You know what else is mathematically consistent? Imaginary numbers. Yet we don't claim they exist in reality.
Your point about falsifiable predictions is valid. However, it's worth noting that not all dimensions are directly measurable or observable. This is where theoretical consistency comes in. Let's take an example from history. In the 19th century, Neptune was discovered not through direct observation, but because its gravitational effects caused anomalies in Uranus's orbit. These couldn't be explained by Newton's laws unless there was another planet out there. Similarly, extra dimensions might be causing phenomena that we can't explain with our current three-dimensional understanding. Regarding your comparison to imaginary numbers, did you know that while they may seem imaginary, they're crucial in various fields of study like electrical engineering and quantum mechanics? They're used to describe real-world phenomena, such as electromagnetic waves and quantum mechanics. So, just because something sounds imaginary doesn't mean it doesn't have a tangible impact on reality.
You're right about Neptune's discovery. But here's the key difference. Neptune was predicted based on gravitational anomalies that were directly measurable. Extra dimensions, on the other hand, aren't producing any measurable effects that we know of. They're more like dark matter. We infer its existence because it makes our equations work out nicely. As for imaginary numbers, yes, they are used in engineering and physics, but they represent concepts, not physical entities. It's like using negative numbers to represent dead. It doesn't mean we have negative dollars in our wallet. Similarly, just because extra dimensions help us in mathematics doesn't mean they exist in reality. Lastly, let's discuss the role of mathematics in physics. Math is a tool we use to describe the universe. It's not a crystal ball that predicts new entities.
Your argument about mathematics being merely a tool to describe the universe seems flawed. It's like saying a blueprint doesn't predict the structure of a building because it's just a tool architects use. But isn't the blueprint essential in predicting and guiding the construction process? Similarly, theories like string theory and M-theory, which suggest the existence of extra dimensions, serve as blueprints for our understanding of reality. Now, let's turn to M-theory, an extension of string theory that proposes 11 dimensions. According to physicist Edward Witten, who first proposed M-theory, these extra dimensions could be compactified or hidden from our perception. This is akin to how a garden hose looks one-dimensional from afar, but reveals its two-dimensionality upon closer inspection, its length and its circular cross-section. Yes, we lack direct empirical evidence for extra dimensions. However, history has shown that empirical evidence often lags behind theoretical predictions in science.
Your analogy of a blueprint predicting a building is interesting. But let's not forget, a blueprint is based on observable and measurable properties like length, width, and height. Can the same be said about extra dimensions? Now on to M-theory. It does propose 11 dimensions, as you mentioned. But just because Edward Witten proposed something doesn't make it true. It's like saying unicorns exist because I proposed they do. We need more than proposals, we need proof. Lastly, you talk about history showing that empirical evidence often lags behind theoretical predictions in science. That's true in some cases, but remember the Large Hadron Collider? It was supposed to reveal higher dimensional particles according to some theories, yet it didn't. So, while we wait for this lag in evidence to catch up with theory, should we blindly accept the existence of extra dimensions? I think not.
Regarding your point about the Large Hadron Collider, it's essential to remember that absence of evidence is not evidence of absence. The collider's failure to reveal higher dimensional particles doesn't disprove their existence, but merely indicates our experiments aren't sophisticated enough yet. It's like trying to catch a whale with a fishing net meant for small fish. Just because you don't catch a whale doesn't mean they don't exist. As for the ethical implications of resource allocation for theoretical research, consider this. Would we have achieved breakthroughs like quantum mechanics or general relativity if resources were only allocated based on immediate empirical proof? Scientific progress often involves venturing into the unknown and investing in ideas that might seem far-fetched at first. According to a 2020 report by the American Institute of Physics, investments in theoretical physics have led to advancements in technology and healthcare, demonstrating its real-world impact. Finally, I agree we need more than proposals. We need continued investigation.
You say absence of evidence isn't evidence of absence. I agree, but we should also consider the principle of naturalistic simplicity. It cautions us against assuming unobservable entities like extra dimensions unless they significantly enhance our understanding of nature. Right now, they don't. Regarding M-theory and its importance to extra dimensions, yes, it does propose 11 dimensions. But again, proposals aren't proof. Did you know that there are other theories like loop quantum gravity that don't require extra dimensions to unify quantum mechanics and gravity? Shouldn't we explore those as well instead of fixating on M-theory? Lastly, concerning future discoveries, rejecting the existence of extra dimensions doesn't limit us. In fact, it might open new avenues for exploration within the bounds of our current knowledge. We shouldn't be afraid to challenge existing theories or assumptions if they lack empirical support. That's how science progresses.
Your mention of loop quantum gravity is interesting. However, it's important to note that just as M-theory doesn't provide empirical evidence for extra dimensions, loop quantum gravity also fails to provide empirical proof for its own assertions. It's like being in a maze with multiple paths leading to the exit. Just because one path seems simpler doesn't necessarily mean it's the correct one. Regarding naturalistic simplicity, did you know that even Albert Einstein cautioned against oversimplification? He famously said, "Everything should be made as simple as possible, but not simpler." Applying this to our debate, while we should prefer simpler theories when all else is equal, we shouldn't dismiss complex ones simply because they're hard to grasp or currently lack empirical support. Lastly, challenging existing theories is indeed how science progresses, but so is exploring new theoretical possibilities and pushing the boundaries of our knowledge, even when these ideas seem radical or unprovable in the present moment. Just ask Galileo or Einstein.
I agree that both M-theory and loop quantum gravity lack empirical evidence. But isn't it interesting that the latter can explain the universe without resorting to extra dimensions? It's like finding a direct route to your destination instead of taking a detour. Regarding Einstein's caution against oversimplification, I agree. But let's not forget his other famous quote, "If you can't explain it simply, you don't understand it well enough." Could it be that our understanding of extra dimensions is not yet refined? Finally, regarding radical ideas in science, they are indeed essential for progress. But so is skepticism. After all, Galileo faced opposition from those who clung to established beliefs without questioning them. Similarly, we should question the existence of extra dimensions until they're substantiated by experimental evidence. That's not limiting science. That's pushing for clarity and precision in our understanding of the universe.
You're right that loop quantum gravity doesn't require extra dimensions. However, its ability to explain the universe is still a matter of debate among physicists. It's not necessarily a direct route, but more like an uncharted path that might lead to our destination. We can't discard other paths just because one seems more straightforward. Regarding Einstein's quote about simplicity and understanding, it indeed suggests that our comprehension of extra dimensions needs refinement. But remember, this refinement often comes from pushing boundaries and exploring new theoretical possibilities, even if they seem complex or counterintuitive initially. Lastly, I wholeheartedly agree with your point on skepticism being essential for scientific progress. However, skepticism should inspire further research rather than halt exploration of ideas lacking current empirical support. As Carl Sagan once said, extraordinary claims require extraordinary evidence. So let's continue investigating the extraordinary claim of extra dimensions rather than dismissing it prematurely due to lack of evidence at this moment in time.
This debate was certainly thoughtful and well-structured, with both participants defending their views with strong analogies, with the believer in extra dimensions having scored more than 30 points. Let's take a look at some statistics. The discussion highlighted the tension between empirical evidence and theoretical elegance, making this a very informative and fun debate. I hope you enjoyed our video. Let us know what debate we should do next. And subscribe on your way out.